Number 1. Operation Wigwam. You're on the deck of a Navy destroyer 500 miles southwest of San Diego. It's May 1955. Beneath you, a 30-kiloton nuclear warhead hangs from a steel cable at 610 meters depth, twice the yield of Hiroshima, and they're about to set it off. The pressure wave hits before you see anything. Then the surface lifts. A dome of white water swells 900 feet into the air. Beneath it, a gas bubble 1,000 feet across collapses, rebounds, collapses again, sending shockwaves through the water column that register on seismographs in Alaska. Magnitude 5.0. An earthquake manufactured from scratch in the middle of the open ocean. This is Operation Wigwam, the only deep-water nuclear test the United States ever conducted. 29 ships, 6,800 personnel, 3 unmanned submarines positioned at varying depths and distances to see how much punishment a hull can take before it buckles. The answer, as it turns out, is not much. But the submarines weren't the only things that buckled. Every living organism within a radius of 1 to 2 nautical miles was annihilated, vaporized, ruptured, or crushed by the cavitation zone that formed around the blast. A cavitation zone is a sphere of near vacuum that forms when the explosive energy displaces water faster than the surrounding ocean can fill the void. When that void collapses, it generates secondary shock waves, pressure pulses that radiate outward like aftershocks, lethal to any organism with a swim bladder, a shell, or a body cavity. Deep pelagic species that had never been cataloged, creatures that had lived in the mid-water column for millennia, erased in a fraction of a second, and nobody counted them. Nobody even tried. Marine biologists aboard the observation vessels were barred from publishing independent assessments. The fish kills were observed but never formally quantified. The Navy wasn't there to study marine biology. They were there to study killing submarines. What was quantified decades later when the dosimetry records were finally declassified in the year 2000 was the radiation exposure. Radioactive seawater was sucked into the cooling and ventilation systems of multiple manned ships. Personnel received doses that exceeded the safety threshold set by the Atomic Energy Commission. The water column temperatures at the blast epicenter were temporarily elevated by hundreds of degrees, creating a localized dead zone where nothing could survive even after the shock waves dissipated. Veterans of Operation Wigwam spent decades fighting to have their exposure recognized under the Radiation Exposure Compensation Act. Many of them didn't live long enough to see it happen. And the ocean floor? Sediment sampling at the blast site, conducted years afterward, found residual radionuclides still embedded in the abyssal mud, 16,000 feet down, in sediment that hadn't been disturbed since the Pleistocene. The bomb worked. The ocean remembered. Number 2, Project Chase. But if one blast could scar the Pacific, imagine what happens when you turn the Atlantic into a chemical weapons cemetery and then walk away for 60 years. Project Chase. The acronym stands for Cut Holes and Sink 'em, which tells you everything you need to know about the sophistication of the plan. Between 1964 and 1970, the United States military loaded obsolete chemical munitions onto surplus cargo ships, towed them out beyond the continental shelf, and sank them. Mustard gas, VX nerve agent, sarin. 64 million pounds of it at minimum. The true total is almost certainly several times higher because Cold War record-keeping was charitably incomplete. The most notorious operation was Chase 10 in 1968. The SS Corporal Eric G. Gibson was loaded with 3,000 tons of M55 rockets filled with VX nerve agent, one of the deadliest substances ever synthesized by human hands. A single drop of VX on exposed skin can kill a grown adult in minutes. It works by inhibiting acetylcholinesterase, the enzyme that tells your muscles to stop contracting. Without it, every muscle in your body contracts simultaneously and doesn't let go. Your diaphragm locks. You suffocate. 3,000 tons of that, sealed in rockets, sealed in a ship, and sent to the bottom of the Atlantic in 7,000 feet of water. The logic was simple. The ocean is big, the water is deep, and the pressure will keep everything in place. Except steel corrodes. And at abyssal temperatures 1 to 4 degrees Celsius, mustard agent doesn't break down. Its half-life in those conditions stretches into hundreds of years. By 2001, a daily press investigation had identified at least 26 chemical weapons dump sites off the American coastline alone. Deep-sea ROV surveys at known sites found corroded munitions lying in open sediment, with visible discoloration spreading across the surrounding seafloor. And it's not just an American problem. The International Dialogue on Underwater Munitions estimates that over 1 million tons of chemical weapons were dumped globally in the oceans between 1917 and 1970. Italian fishermen have been accidentally trawling up World War I-era mustard shells from Adriatic dump sites for decades, suffering chemical burns from munitions that are more than a century old. In 2004, a clam dredging vessel off New Jersey pulled up a mustard gas shell that hospitalized 3 crew members. The ocean floor isn't just contaminated, it's armed. A 2012 Belgian study found that mustard gas shells dumped in the North Sea after the First World War were still producing genotoxic degradation products after more than 90 years. These aren't inert relics, they're actively generating compounds that damage DNA in any organism that comes into contact with them. A 2010 report by the Medea Group, a scientific advisory panel to U.S. intelligence agencies, concluded that leaked chemical agents were entering the marine food chain through benthic organisms. The U.S. Army's official position, maintained into the 2020s, is that deep ocean conditions neutralize chemical agents. Every independent study says otherwise. And here's the paradox that keeps remediation experts up at night. Disturbing the dump sites to remove the munitions could cause more immediate contamination than leaving them to slowly corrode in place. You can't dredge a VX rocket without risking rupture. You can't detonate it in place without dispersing the agent. You can't leave it alone because the casing is disintegrating. The graves are opening. And there's nothing clean about what's inside. Number 3, Soviet Arctic nuclear dumping. If America sank nerve gas, the Soviet Union went nuclear, literally. Between 1959 and 1992, the USSR dumped an estimated 17,000 containers of radioactive waste, 19 vessels loaded with radioactive material, and 14 nuclear reactors into the Arctic Ocean. 6 of those reactors still had their fuel assemblies inside. The primary dumping grounds were the Kara Sea, the Barents Sea, and the fjords around the Novaya Zemlya archipelago, the same stretch of Arctic coastline where the Soviets conducted atmospheric nuclear tests, including the 50-megaton Tsar Bomba. The most alarming single object on the Arctic seabed is the submarine K-27, scuttled in Stepovogo Fjord in 1981. It sits in only 33 meters of water, shallow enough for a recreational diver to reach with its nuclear fuel still loaded. The nuclear icebreaker Lenin's damaged reactor core was dumped in Suwalki Fjord after a 1967 accident. Containers designed for a 25 to 50-year lifespan have now far exceeded their engineering limits, and many were built to standards that would be considered dangerously inadequate by any modern measure. Some were simply concrete-lined steel barrels, others were reactor compartments cut from decommissioned submarines and rolled off the deck of a transport ship. None of this was publicly known until 1993, when a Russian government commission headed by Dr. Alexei Yablokov produced a document that became known as the White Book. It revealed the full scale of the dumping for the first time, and the international community reacted with something between horror and disbelief. The total radioactivity deposited on the Arctic seabed was approximately 2.5 million curies, roughly comparable to the radioactive release from the Chernobyl disaster. Except Chernobyl was an accident. This was policy. Norwegian and Russian joint expeditions in the 1990s and 2000s measured elevated levels of cesium-137, strontium-90, and plutonium isotopes in sediments near the dump sites. Elevated radionuclide concentrations were detected in Arctic cod and bottom-dwelling organisms. A 2012 ROV survey of Abrosimov Fjord found containers with visible rust holes and collapsed structures. The London Convention of 1972 had explicitly prohibited ocean dumping of high-level radioactive waste. The Soviet Union continued dumping for another 20 years. Now climate change is accelerating the problem. Permafrost thaw and shifting Arctic currents are speeding up corrosion. The Northern Sea Route, increasingly used for commercial shipping as Arctic ice retreats, runs directly through areas adjacent to dump sites. Russia's own 2021 environmental assessment upgraded several Novaya Zemlya sites from stable to requiring urgent intervention. The estimated cost of full remediation is $5 to $10 billion. Nobody is paying. Over 18,000 individual radioactive objects sit on the Arctic seabed, the single largest deliberate introduction of radioactive material into any ocean in human history. And the containers weren't built to last this long. Nobody thought they'd need to. Number 4. Iron fertilization experiments. Not every forbidden experiment involved dumping poison. Some involved feeding the ocean and watching it react in ways nobody predicted. In 1990, oceanographer John Martin stood before a room full of colleagues and made one of the most provocative claims in the history of marine science. "Give me half a tanker of iron," he said, "and I'll give you an ice age." His iron hypothesis proposed that vast stretches of the ocean, the so-called high-nutrient, low-chlorophyll regions, were biologically unproductive not because they lacked nitrogen or phosphorus, but because they lacked iron. Add iron, Martin argued, and you'd trigger enormous phytoplankton blooms that would absorb atmospheric carbon dioxide and drag it to the ocean floor. Geoengineering on a planetary scale using nothing but rust. Between 1993 and 2012, at least 13 major open ocean iron fertilization experiments tested this hypothesis. Iron X2, in 1995, dumped tons of iron sulfate into the equatorial Pacific and produced a bloom covering 1,000 square kilometers, visible from satellite. It proved Martin's basic hypothesis was correct. But proving you can grow plankton and proving you can sequester carbon turned out to be very different things. SOFEX, the Southern Ocean Iron Experiment of 2002, found that while blooms occurred, the amount of carbon that actually sank to the deep ocean was far less than predicted. Most of it was recycled in surface waters. The ocean was eating its own medicine. LOHEFEX, a joint Indo-German experiment in 2009, was the most controversial. The Convention on Biological Diversity had issued a de facto moratorium on ocean fertilization the year before. LOHEFEX went ahead anyway. The results were even more deflating. Zooplankton grazed down the bloom before any significant carbon could sink. The experiment produced negligible sequestration. Then, in 2012, the situation went rogue. American businessman Russ George conducted an unauthorized dump of approximately 100 tons of iron sulfate off the coast of Haida, Gwaii, British Columbia. He claimed it was a salmon restoration project. Environment Canada launched a criminal investigation. Satellite imagery confirmed the dump triggered a bloom of roughly 10,000 square kilometers, one of the largest artificial blooms ever documented. The London Protocol was amended in 2013 specifically to regulate marine geoengineering. The risks aren't theoretical. Large-scale iron fertilization can trigger toxic algal blooms that produce neurotoxins like domoic acid, the same compound responsible for mass die-offs of sea lions and pelicans along the California coast. As artificial blooms die and sink, bacterial decomposition depletes dissolved oxygen, potentially creating dead zones where nothing aerobic can survive. Changes in plankton composition cascade through the food web, altering zooplankton populations, fish larvae survival, and commercial fisheries. A 2019 review in the Annual Review of Marine Science concluded that iron fertilization has no demonstrated capacity for meaningful carbon sequestration at scale. The ocean is not a machine with a single lever. Every dial you turn moves 100 others. Number 5. Bikini Atoll, Operation Crossroads. But if iron fertilization was an attempt to manipulate the ocean's chemistry, what happened at Bikini Atoll was an attempt to break its physics. July 25, 1946. You're standing on the deck of an observation vessel in Bikini Lagoon, Marshall Islands. 95 warships are arranged around you in concentric rings: battleships, aircraft carriers, cruisers, destroyers, submarines, captured German and Japanese vessels, a floating zoo of military hardware assembled for one purpose: to see what a nuclear bomb does to a navy. The device is a 23-kiloton Mark III weapon suspended at 27 meters beneath the lagoon's surface. They call the test Baker. The lagoon lifts. A column of white water, 600 meters in diameter, erupts upward to a height of 1,800 meters. A condensation dome forms over the blast site, a perfect Wilson cloud nearly a mile across. Then comes the base surge, a wall of radioactive mist rolling outward at hurricane speed across the surface of the lagoon, coating every ship, every surface, every piece of equipment with intensely radioactive seawater. The base surge was far more radioactive than anyone had predicted. Most of the target ships were too contaminated for human boarding for weeks. The LSM-60, a landing craft positioned directly above the bomb, was never found. It had been vaporized. 42,000 U.S. military personnel participated in Operation Crossroads. Many were sent to board and decontaminate the target ships wearing nothing more than standard work clothes and rubber gloves. They scrubbed decks with seawater and lye soap, not understanding that the radioactive contamination had bonded with the metal surfaces at a molecular level. No amount of scrubbing would remove it. Veteran health studies decades later documented elevated rates of cancer, leukemia, and other radiation-related diseases among participants. The 167 indigenous Bikinian people had been relocated before the tests with promises they could return. They never did. Bikini Atoll remains uninhabitable. The compensation offered, $150 million under the 1986 Compact of Free Association, was a fraction of the $2.2 billion in damages assessed by the Nuclear Claims Tribunal. The lagoon floor was irradiated by Baker. Sediment contamination with cesium-137 and plutonium-239/240 persists to this day. The United States went on to conduct 67 nuclear tests in the Marshall Islands with a combined yield of approximately 108 megatons, the equivalent of 1.6 Hiroshima bombs every single day for 12 years. The coral reefs were devastated. Approximately 70% of the reef system was destroyed. But here's the strange twist. A 2008 survey by marine biologist Zoe Richards found that Bikini's reefs had significantly recovered in the absence of human habitation. The sunken warships in the lagoon have become artificial reef ecosystems. The USS Saratoga, the USS Arkansas, and the HIJMS Nagato, the Japanese flagship from Pearl Harbor, are now colonized by coral, sponges, and fish. The lagoon is healing itself. But it's still too radioactive to eat what lives there. The reef doesn't know it's poisoned. The fish don't know they're contaminated. Only the Geiger counter knows. Baker proved something that changed naval warfare forever. Nuclear weapons could contaminate vast areas of ocean for extended periods, rendering them biologically dangerous long after the blast itself had dissipated. It wasn't the explosion that was the real weapon, it was the invisible residue it left behind. Number 6. Rocky Mountain Arsenal Deep Well Injection. Not every experiment that changed the ocean happened in the ocean. Some happened in a borehole in Colorado. The Rocky Mountain Arsenal was a U.S. Army chemical weapons manufacturing facility 10 miles northeast of Denver, operational from 1942 to 1992. It produced mustard agent, lewisite, serine, VX nerve agent. And all of that production generated millions of gallons of liquid toxic waste, which was initially poured into unlined surface evaporation ponds. The ponds leaked, groundwater became contaminated, crops died, livestock died, farmers sued. So in 1961, the Army came up with a solution. Drill a well 12,045 feet straight down, 3.5 kilometers, through layers of sedimentary rock into the fractured Precambrian basement, and pump the waste directly into the Earth's crust. Between 1962 and 1966, approximately 165 million gallons of contaminated fluid were injected under pressure into deep rock. The Army considered the problem solved. Then, Denver started shaking. More than 700 earthquakes struck between 1962 and 1967 in a metropolitan region with virtually no prior seismic history. In 1966, geologist David Evans published a landmark paper directly correlating injection volumes with earthquake frequency. When pumping increased, quakes increased. When pumping stopped, quakes decreased. The correlation was almost perfect. The largest induced earthquake hit on August 9, 1967, magnitude 5.3, causing significant property damage across Denver. The Army permanently ceased injection, but earthquakes continued for years as injected fluids migrated through fracture networks deep underground. This was the first scientifically documented case of human-induced seismicity from fluid injection. It fundamentally changed our understanding of how subsurface pressure affects fault behavior. And it's not just a Colorado problem. The contamination plume from the arsenal spread across 42 square miles of groundwater, reaching the South Platte River watershed, which feeds into the Missouri-Mississippi system and ultimately into the Gulf of Mexico. What was pumped underground in Colorado didn't stay underground. It migrated into watersheds that connect to the ocean across continental distances. The Superfund cleanup cost over $2.1 billion. The site is now the Rocky Mountain Arsenal National Wildlife Refuge, bison and bald eagles living on top of one of the most contaminated places in America. And the lesson it taught, that injecting fluid underground causes earthquakes, went unheeded for decades. Oklahoma's devastating earthquake swarm from 2009 to 2016, when annual quake numbers leapt from 2 to over 900, was caused by the exact same mechanism. High-volume wastewater injection from oil and gas fracking. The deep subsurface is not an isolated disposal zone. It is connected to everything, including the ocean. Number 7. The SOSUS Cold War Hydrophone Network. Sometimes the most revealing experiment is the one you didn't mean to run. In 1954, the United States Navy began installing a secret network of underwater hydrophone arrays on the ocean floor. The system was called SOSUS, Sound Surveillance System, and its purpose was straightforward: track Soviet submarines. SOSUS exploited a quirk of ocean physics called the SOFAR channel, the sound fixing and ranging channel. At approximately 700 to 1200 meters depth, a combination of temperature and pressure creates a layer of minimum sound velocity. Sound waves entering this layer become trapped, bouncing between the upper and lower boundaries, traveling for thousands of miles with remarkably little loss. The Navy strung hydrophone arrays across every strategic choke point in the Atlantic and Pacific: the Greenland-Iceland UK gap, the Azores, the continental shelves. For 4 decades, they listened. When the Cold War ended in 1991, parts of the network were declassified and handed to NOAA's Pacific Marine Environmental Laboratory. Scientists began listening to the ocean for an entirely different reason, and what they heard changed everything. In 1997, sensors across the Pacific recorded a sound so powerful it was detected on multiple arrays more than 5,000 kilometers apart. They called it the bloop. It was eventually attributed to an Antarctic icequake, but the bloop was just the beginning. Other unexplained sounds emerged from the data: Julia, slow down, train, and upsweep, an eerie rising tone that has been detected continuously since 1991 and remains only partially explained. But the real revelation wasn't the mysterious sounds. It was what the SOSUS data showed about what humans had done to the ocean's acoustic environment. Christopher Clark at Cornell University used SOSUS recordings to demonstrate that blue whale communication range had been reduced by approximately 90% since the 1940s. Blue whales call at frequencies as low as 10 to 14 hertz, infrasonic pulses that historically carried across entire ocean basins. Now those calls are drowned out by the low-frequency drone of commercial shipping engines operating at similar frequencies. A 2003 study found that ambient ocean noise in the northeastern Pacific had increased by roughly 10 decibels between 1960 and 2003, a tenfold increase in sound intensity. Military sonar has been directly linked to mass strandings. In 2000, 14 Cuvier's beaked whales stranded and died in the Bahamas during a U.S. Navy mid-frequency active sonar exercise. Necropsies revealed hemorrhaging around the brain and inner ear, acoustic trauma. The Navy's SURTAS LFA system operates at source levels exceeding 215 decibels, powerful enough to cause physical injury to marine mammals at close range. Seismic air guns used in oil and gas exploration produce impulses of over 230 decibels every 10 seconds for weeks at a time. A 2017 study in Nature Ecology and Evolution found that zooplankton abundance dropped by 64% within 1.2 kilometers of seismic airgun surveys. Not fish, not whales. Zooplankton, the base of the marine food web. The irony is brutal. A surveillance system built for Cold War espionage accidentally became the instrument that proved humans had fundamentally altered the acoustic fabric of the ocean. We didn't just listen to the sea, we discovered that we'd already deafened it. Number 8. Minamata Bay, Mercury. Dumping. Some experiments aren't conducted by governments or militaries. Some are conducted by corporations that know exactly what they're doing and choose to do it anyway. Minamata disease was first officially recognized in 1956 in a fishing community on the coast of Kumamoto Prefecture, Japan. But the symptoms, loss of motor control, constriction of the visual field, hearing loss, slurred speech, and in severe cases, insanity and death, had been appearing in local populations since the early 1950s. Cats were the first warning. They began convulsing, staggering in circles, throwing themselves into the sea. The locals called it dancing cat disease. It wasn't a disease. It was poisoning. The Chiso Corporation's chemical factory in Minamata had been discharging methyl mercury contaminated wastewater into Minamata Bay since 1932. Methyl mercury is an organic form of mercury that is extraordinarily bioavailable. It is absorbed with devastating efficiency by aquatic organisms and biomagnifies at each step up the food chain. By the time it reached the fish and shellfish that the community depended on, concentrations were hundreds of times higher than in the surrounding water. Every meal was a dose. In 1959, a researcher in Chiso's own hospital, Dr. Hajime Hosokawa, confirmed through experiments on cats that the factory's wastewater was the cause. Cat number 400 developed the same symptoms after being fed food mixed with chutyu effluent. Chiso suppressed his findings. They didn't just ignore them, they ordered Hosokawa to stop the experiments and forbade him from publishing. He complied. He didn't testify publicly until 1970, on his deathbed, in a court proceeding against his former employer. The Japanese government did not officially acknowledge methylmercury from Chiso as the cause until 1968, 12 years after the disease was identified, during which time the factory continued discharging. 2,265 victims were officially certified. 1,784 of them died. Independent studies estimate the true number of affected individuals at over 50,000. A second outbreak was identified in 1965 along the Ageno River in Niigata Prefecture, caused by a different company, Showa Denko, doing the same thing. Minamata wasn't an isolated incident, it was a pattern. The bay floor accumulated an estimated 150 tons of mercury-contaminated sediment. A massive remediation project from 1977 to 1997 dredged 1.5 million cubic meters of toxic mud and sealed it behind a seawall. Minamata Eco Park now sits on top of it. Children play on land that is beneath a thin engineered barrier, one of the most mercury-contaminated sites on Earth. In 2004, the bay was declared safe. The sediment contamination persists beneath the containment. Minamata's legacy extends far beyond Japan. It led directly to the Minamata Convention on Mercury, adopted in 2013, a global treaty to protect human health and the environment from anthropogenic mercury emissions. It proved with devastating clarity that heavy metals discharged into a localized marine environment don't stay local. They move up the food chain until they find you. A 2019 study in Nature found that mercury levels in Pacific yellowfin tuna had increased approximately 3.8% per year between 1998 and 2013. The mercury in your sushi tonight may have entered the ocean decades ago from a factory that no longer exists in a bay that's been declared clean. Mercury doesn't disappear. It accumulates, and the ocean's memory for poison is very, very long. Number 9. The MV Ievoli Sun. October 31st, 2000. The English Channel. Force 10 storm conditions. The MV Ievoli Sun, an Italian-flagged chemical tanker carrying 6,000 tons of hazardous cargo, is listing so badly that the crew can no longer stand upright. 14 men are airlifted off by helicopter in conditions that make the rescue itself a near miracle. And then someone in the French Maritime Authority makes a decision that will turn a stretch of one of the world's busiest shipping lanes into an uncontrolled chemistry experiment. They let her sink. The cargo manifest listed 4,000 tons of styrene, a neurotoxin and suspected carcinogen, 1,000 tins of methyl ethyl ketone, and 1,000 tins of isopropyl alcohol. The ship went down in approximately 70 meters of water, 12 nautical miles north of Alderney in the Channel Islands. French authorities argued that the chemicals would disperse more safely in open water than if the vessel broke apart during a tow to port. It was a reasonable calculation. It was also a gamble with the marine ecosystem as collateral. Ifremer, France's Oceanographic Research Institute, monitored the site and detected elevated chemical concentrations in the water column for weeks. Fishing exclusion zones were established. Benthic communities within 500 meters of the wreck showed significant reductions in species diversity and abundance. A 2002 study by Cedre found that biological recovery around the wreck was slower than predicted, particularly for sessile organisms that couldn't flee the contamination zone. Styrene polymerizes in seawater over time, potentially creating persistent plastic-like residues on the seafloor. The long-term fate of those residues has never been fully studied. The Ievoli Sun was part of a cluster of marine pollution disasters that struck European waters in rapid succession: the Erika in 1999, the Ievoli Sun in 2000, the Prestige in 2002. Each one prompted regulatory tightening. Each one demonstrated the same fundamental problem. The English Channel sees over 500 commercial vessel movements per day, and the statistical probability of chemical spills is not a question of if, but when. The Ievoli Sun prompted the International Maritime Organization to revise MARPOL Annex II, tightening regulations on how chemical cargoes are categorized and carried. But the wreck still lies on the channel floor. It's periodically monitored. It is no longer considered an acute risk. But nobody asked the organisms living around it whether they agreed with that assessment. Every chemical tanker loss is a large-scale, uncontrolled experiment in marine toxicology. The ocean doesn't get a vote on the methodology. Number 10. The DISCOL Experiment. 4,150 meters beneath the surface of the southeastern Pacific. The Peru Basin. You are on the abyssal plain, one of the flattest, darkest, most silent environments on the planet. The seafloor stretches in every direction, carpeted with manganese nodules. Potato-sized mineral concretions composed of manganese, nickel, cobalt, copper, and rare earth elements. Each one grew at a rate of approximately 1 to 10 millimeters per million years. Some of the nodules beneath you have been forming since before the genus Homo existed. They are, in a geological sense, among the slowest things on Earth. In 1989, a team of German marine scientists led by Dr. Hjalmar Thiel brought a plow. The DISCOL Experiment, Disturbance and Recolonization used a plow-harrow device towed behind the research vessel Sun to systematically churn a circular area of 10.8 square kilometers of abyssal seafloor. The purpose was to simulate what would happen if a commercial mining operation scraped up the manganese nodules for their metal content. It was a controlled disturbance, deliberate, measured, scientific. And it produced results that should have stopped the deep-sea mining industry before it started. The site was revisited in 1992, 3 years after the plowing. The tracks were still clearly visible on the seafloor. Recolonization by macrofauna was minimal. In 1996, 7 years later, some mobile species had returned, certain polychaetes and nematodes. But sessile organisms and fauna that depend on nodules as hard substrate, sponges, corals, foraminiferae that attach to nodule surfaces were absent. They couldn't come back until new nodules formed, and new nodules form at a rate of millimeters per million years. The landmark revisit came in 2015, 26 years after the original disturbance. Led by Antje Boetius at the Alfred Wegener Institute, the team published their findings in Science Advances. After more than a quarter century, microbial activity in the disturbed sediment had recovered to only about 54% of undisturbed levels. The plow tracks were still visible. The ecosystem had barely begun to heal. To put that in perspective, in the 26 years between the plowing and the revisit, the Berlin Wall fell, the Soviet Union dissolved, the internet was invented, and the entire digital age unfolded. The abyssal plain didn't notice. It was still trying to recover from an afternoon, and the damage extended far beyond the plowed zone itself. The sediment plumes generated during the disturbance had settled over a surrounding area estimated at 3 to 4 times the size of the directly churned area, blanketing filter-feeding organisms and altering sediment chemistry across a much wider footprint than anyone had predicted. DISCOL is now the primary piece of empirical evidence cited by environmental groups and marine scientists opposing commercial deep-sea mining in the Clarion-Clipperton Zone, a vast stretch of the Central Pacific that contains an estimated 21 billion tons of manganese nodules. 19 contractors hold exploration licenses from the International Seabed Authority. The metals company argues that seabed mining has a lower carbon footprint than terrestrial mining for the same metals. Critics point to DISCOL and ask a simple question: what is the acceptable recovery time for an ecosystem? Because the answer, based on the only experiment we've ever run, is longer than human civilization has existed. A 2021 study by Stratman and colleagues found that even light disturbance to abyssal sediments releases sequestered carbon and nutrients, potentially creating feedback loops that affect ocean chemistry at scale. The abyssal plain isn't a wasteland. It's a carbon sink, a mineral nursery, and a living ecosystem that operates on timescales so slow they make human activity look like a seizure. The plow tracks from 1989 are still visible on the seafloor today. They will be visible long after every building currently standing on Earth has crumbled to dust. 10 experiments, 7 decades, every ocean on the planet. Nuclear warheads detonated in the deep Pacific. Nerve gas scuttled in the Atlantic. Reactor cores dumped in the Arctic. Iron poured into the Southern Ocean. A lagoon turned into a radioactive graveyard. Toxic waste pumped into bedrock until the ground shook. The acoustic environment deafened by the very systems designed to listen. Mercury fed through an entire food chain until it reached the nurseries. Chemical tankers left to leak on the channel floor. An abyssal plane plowed to see what would happen, and what happened was nothing recovered. The common thread isn't cruelty, it's assumption. Every one of these experiments operated on the same foundational belief that the ocean is too vast, too deep, too indifferent to be permanently damaged. Dilution is the solution to pollution. That was the governing philosophy of 20th century ocean disposal. The ocean was treated as an infinite sink. Pour enough water over anything, and it disappears. It doesn't disappear. It redistributes. The radionuclides in Bikini's sediment, the mustard agent leaching from Atlantic dump sites, the mercury cycling through tuna stocks in the open Pacific, the silence where whale song used to carry across entire ocean basins, the plow tracks on the abyssal plain, still visible after 26 years, waiting. The ocean keeps records, in sediment, in bone, in sound, in the slow growth of manganese nodules that won't reform for another million years. It records what we do with the patience that makes human memory look like a mayfly's lifespan. And the pattern of concealment runs through every case like a second thread. Chiso suppressed Cat 400 and silenced Hosokawa. The Navy classified Wigwam's dosimetry for decades. The Army denied the injection seismicity link until the earthquakes became undeniable. The Soviet Union hid the Yablokov data behind state secrecy until the state itself collapsed. In every case, the secrecy served the same function. It prevented correction. If the data is classified, nobody can object. If the findings are suppressed, nobody can stop the discharge. If the scale of the dumping is hidden, nobody can demand remediation. Secrecy didn't just enable these experiments, it extended them. International law always arrives as a post-mortem. The Ocean Dumping Act of 1972 was passed after Project Chase was exposed. The London Convention banned high-level radioactive waste dumping the same year, and the Soviet Union ignored it for another 2 decades. The Minamata Convention was born from 60 years of suffering. The London Protocol was amended after Russ George's rogue iron dump. The ISA mining code is still being debated, with DISCOL's evidence sitting on the table like an accusation nobody wants to read. Every treaty was written in response to a disaster that had already happened. None of them prevented it. The ocean has no seat at the negotiating table. It has no vote, no lobby, no delegation. It just absorbs until it can't. And the experiments haven't stopped. They've just changed form. Deep-sea mining exploration is accelerating in the Clarion-Clipperton Zone, despite everything DISCOL proved. Anthropogenic ocean noise continues to increase as global shipping tonnage grows year after year. Microplastics have been found at the deepest point of every ocean trench on Earth. Climate change is running the largest uncontrolled experiment of all: ocean acidification, deoxygenation, thermal stratification, on a planetary scale with no control group and no off switch. We are altering the chemistry of the entire ocean simultaneously, and we are doing it faster than at any point in the geological record. The last time ocean pH shifted at anything close to this rate was the Permian-Triassic extinction, the Great Dying, when 90% of marine species were erased. The most dangerous assumption in human history is that the biggest thing on Earth is too big to break. The evidence is in the sediment. The evidence is in the silence. The evidence is in those plow tracks on the abyssal plain, scars from 1989 that will outlast everything we've ever built. The ocean is patient, but it is not forgiving, and it remembers everything.